On to our next lesson, finding a missing side. So this lesson, I think, should be expanded a little bit, the title. And specifically, we're talking about right angle triangles, or I call them right triangles. So we can go through the list here. If we are given one side and one angle, we can use the trig ratios to find the length of another side. So before we get on to the main lesson, I am just going to take one trigonometric ratio, but it holds true for all of them. So we have tangent theta is equal to opposite over the adjacent. What we notice is that there is 1, 2, 3 pieces of information in any trigonometric ratio. Now, the angle is one piece of information, and by the way, if you have the angle theta, you can easily determine tangent theta with your calculator. So in order to solve a missing piece of information, an angle or a side, you need the two other pieces of information. So for example, if you're trying to find the opposite side, you would need to know the angle and the adjacent side. And this holds true for most math equations. If you have one equation, you need only one unknown in order to solve it. The instant that you have two unknowns, you are not able to solve it. So let's go on to the lesson, and what we're going to do is to find the missing side. So given the angle, we need to, using the given angle, identify two sides that you're working with. In other words, label your triangle. Really important. Then, using the given information, we're going to find the trigonometric ratio that we're talking about. We're going to set up the equation, and then, quite simply, we are going to solve. All right. So if I'm trying to solve for x here, what I'm going to do is I'm going to call this angle theta. So given the angle that I'm working with, I have to have theta. If this is theta, this side is the hypotenuse. The x side is going to be the beside side, or it's the side adjacent to theta. And if you notice, I'm not going to label opposite because opposite's really not involved in my triangle. So given, I'm going to ask myself, in the three basic trigonometric ratios, what ratio has adjacent and hypotenuse? And that is going to be the cosine ratio. So I'm simply going to write down my ratio. The next thing that I am going to do is I'm going to plug in the information that I know. And theta is 64, so the cosine of 64 degrees. So instead of writing theta, write 64 degrees. My adjacent is what I need to know, finding out. X is my unknown. My hypotenuse is 14. Now, keep in mind that cosine 64 is just a number. Algebraically, how would you solve if we have A is equal to B over C? How would you solve for the unknown B? Well, you would multiply both sides by C, would you not? And that's exactly what we're going to do here. We're going to multiply both sides by 14. And so cosine of 64 degrees, I'm going to make sure that's put into brackets, times 14 is equal to x. Now, depending on your calculator, make sure you figure out this cosine of 64. I know that in my calculator, I have to make sure that I close off the bracket. in my calculator prompt. And the answer that I get is x is equal to 6.1371. Now, what I'm going to do is I'm going to round to 3 decimal places. 6.137. And that seems to align with my picture. It seems totally reasonable that I have a hypotenuse of 14, and this side is 6.137. Right? You know you would have had it wrong if you had x is equal to 15, because the hypotenuse has to be the largest side. Let's move on to this next example. So I'm going to challenge you now. If I have A is equal to B over C, how would you solve for C algebraically? Well, that's a good question. Well, step number 1 maybe is I could write A is over 1. I could take the reciprocal of both sides. And now, if I'm solving for C, I would just multiply the denominator by B. Or sorry, multiply both sides by B. So I'd get B over A is equal to C. I know a lot of you guys cross multiply. Now, I would like to get you away from that because there's really limited knowledge in that. It's just a trick that you guys do in order to solve for C. Another thing that we can do to solve for C is that you could multiply both sides by C. And you would get AC is equal to B. And then you would take a look, hey, if I'm solving for C, I would divide both sides by A to isolate C. And perhaps that's the method that I'm going to be using now. All right. I take a look at my triangle. I'm trying to find this side, whatever this side might be. I'm given an angle 40 degrees. I'm going to call that theta. Now, with respect to theta, or pretending I'm theta, this side is the hypotenuse. This side is the adjacent. So then I have to ask myself, what trigonometric ratio uses hypotenuse and adjacent? Well, that's cosine. Cosine theta is equal to the adjacent over the hypotenuse. Now, if you notice what I'm doing, I'm actually writing out the trigonometric ratio. I'm not plugging in numbers immediately. So cosine 40 degrees is equal to x over 7. In other words, x is equal to 7 times the cosine of 40 degrees. And my calculator is can easily figure that out. And that's 5.362.